So here we'll look at logarithmic differentiation. And we do this because some derivatives can be simplified and sometimes even need to be simplified using logs. And the best way to understand is to look at an example. So say we wanted to find the derivative of a function y is equal to x to the 5 over 1 minus 10x times the square root of x squared plus 2. So our general process for this kind of derivative calculation is to take logs of both sides. After we've done that, we can differentiate both sides, keeping implicit differentiation in mind. This is when y becomes y as a function of x, so we have to differentiate with the chain rule. After we do that, we can solve for dy dx. So let's differentiate. If we take logs, so step 1 is to take logs. If we take logs of both sides, we'll get that ln y is equal to ln of x to the 5 minus ln of 1 minus 10x times x squared plus 2 square root. Okay, but using log laws, this is equal to ln x to the 5 minus ln of 1 minus 10x plus, in brackets, ln x squared plus 2. Okay, then this is equal to ln x to the 5 minus ln 1 minus 10x minus ln root x squared plus 2. Okay, now let's differentiate. So step 2 is to differentiate both sides. If we differentiate the left-hand side, we're going to get that we have 1 over y times dy dx using the chain rule. This will be equal to 1 over x to the 5 times the derivative of x to the 5. So that will be times 5x to the 4 minus the derivative of ln 1 minus 10x, which will be equal to 1 over 1 minus 10x minus the derivative of that, which is minus 10. Sorry, times the derivative of that, which is minus 10. Looking at the last term, we have that's going to be minus 1 over root x squared plus 2 times the derivative of that, which would be a half 2x times x squared plus 2 to the minus a half. If we simplify this, we'll get 5 over x plus 10 over 1 minus 10x minus x over x squared plus 2. And now we see that we can isolate dy dx, and we have also already been given our function for y. So plugging y in and solving for dy dx, we get that dy dx will be equal to y times 5 over x plus 10 over 1 minus 10x minus x over x squared plus 2, which is equal to x to the 5 over 1 minus 10x square root x squared plus 2 times this bracket, 5 over x plus 10 over 1 minus 10x minus x over x squared plus 2. And that is our final answer, even though we can't see it very well. I hope you heard me better. But there actually is more applications of logarithmic differentiation. So we can also use logarithmic differentiation to solve functions of the form where y is equal to a function of x that is all to the power of another function of x. So if we do another example, and I think this time we will do it in yellow, and we take logs of both sides. So again, we'll have ln y is equal to x ln x using log-logs. Then we can differentiate both sides, so we're going to get 1 over y dy dx is equal to, using the product rule, we'll get ln x plus 1. And now solving for dy dx, we have dy dx equal to y times ln x plus 1 in brackets, which is equal to x to the x ln x plus 1. And that's logarithmic differentiation.